Hello. Today we're going to talk about functions. And the reason that we're going to talk about functions is because oftentimes in calculus, we're concerned with understanding the behavior of some function. So before we try and do that, it makes sense to understand what a function is. So to get started, a function can be thought of as a special kind of relationship. And I'm going to use the example of studying to explain what I mean. Suppose that you have some material that you're studying, represented by this nicely drawn piece of paper. And moreover, you spend some time studying. Then what I'm going to do is take all of the effort that you spend studying and put it in this box. Label it effort. And you're going to expect to get some knowledge out of the effort that you put in for studying, hopefully. And to signify this, I'm going to draw a one-way arrow from effort to knowledge. And this is great for understanding and expressing that there is some relationship between effort and knowledge. But suppose that you want to go one step further and understand exactly what that relationship is. You might take measurements over time. And if you were able to find a way to measure the specific knowledge that you gained, I don't know how you would do that, but suppose that you can, and you took measurements at 1, 2, 3, 4, and 10 hours. And at 1 hour, you gained 1 unit of knowledge, 2 hours, 2 units, 3 units, 3.5 units at 4, and at 10 hours, you realize you had only gained 4 total units of knowledge. Great. So now you know what you can expect for a certain amount of time put into studying. Say that you want to understand more visually what this means. You might draw a graph, right? So if I draw this arrow up here and drew a graph with knowledge on the vertical axis and time on the horizontal axis in hours. And to be explicit, we can label the axes. And forgive me, this is most definitely not to scale. We would see that we have 1, 2, 3, and here at 4, it's probably that. And we know it doesn't go any higher than 4 by the time 10 comes around, so we're going to say that it levels off there. So we can draw a line roughly through these points. And there's actually been a study done on this. This is pretty accurate as far as what you might expect to see when you're actually studying. Fun fact. And at this point, we have a graph and a table. And we are well positioned to ask the question, is this curve that represents the relationship a function? And the answer is yes. But you might ask, how do you know that? And I would say that a function is a relationship in which there is one unique output for each unique input. So people often use the vertical line test, which is if I draw a vertical line through the graph and I were to draw that vertical line anywhere, in no place would it cross the curve in more than one spot. So here we can see it crosses the curve in one spot, and no matter where we put it, it wouldn't cross more than once. So it is indeed a function. An example of a graph that isn't a function would be, say, you had, I'll just say K and T for knowledge and time. If your study curve looked something like this, then you would see that you could get different amounts of knowledge, 1, 2, 3, for a specific amount of time that you put in studying. So this is not a function. Now, at this point, we've gone over a couple of different methods of representation for functions and more informally defined what a function is. So now that you have a basic idea, I'm just going to go through and briefly introduce a couple of other methods of representing functions that you might commonly see. The first of which being the algebraic method of representation, which is really just a fancy way to say an equation. And we might use an equation to represent our function f of x, where f of x you might be more used to seeing it as y. Here, f is just the more common way of saying function, and of x is saying that it is a function of our input variable x. So f depends on x. And here x is time, the time that we spend studying in our example. So also in our example, we might recognize this as the shape of a logarithm. Now, don't worry if you don't understand what that means quite yet. We have some other videos that you can go through and understand more about what specific types of functions are, what certain families are. But for our case, we're just going to say that our plot has the form log base a of x. And really, I just wanted to write that so that if you see this, you'll know that this is just another way of representing a function, and it could be alternatively represented using a graph or maybe even a table. And the last, and probably least popular way that I've seen of representing a function is using these kinds of circle diagrams, or set diagrams they're sometimes called. And really, these circles just contain all of the points in your input space, they call it. So all the possible times that you might spend studying. And in the other circle is your output. So it's the amounts of knowledge that you might gain. And by definition of a function, we know that each point in time corresponds to a specific amount of knowledge gained. So that means that if we have a number of dots in each of these circles, that one dot in time, in the time circle, is only going to point to one dot in the knowledge circle. But you could have two dots in the time circle pointing to one dot in the knowledge circle. An example of this would be, say, if you had a function that was a horizontal line, then for any amount of time, say no matter how long you studied, you only got 2 units of knowledge out of it. Every point in this time circle would point to 2 in the knowledge circle. And I think I'm going to stop here for now. If you would like to learn more about functions and calculus and just engineering in general, then go on and subscribe to the Engineering channel and head on down. We've got more videos about those topics. As always, thanks for watching. If you enjoyed the video or you learned something new, let me know by liking the video and commenting below.